provide the formulas for the area as well as the circumference of the following figures. First of all, we'll take a look at the trapezium, which will be that first figure there. Now the area of a trapezium is a half times by the sum of the parallel sides times by the height. In other words, you take, let's say that is x and that is y centimeters or millimeters or whatever. You put x plus y in a sum first, multiply by a half, and then multiply by the perpendicular height of the trapezium. So that will then give you the area. The circumference will literally just be the sum of all four sides. So that plus that plus that plus that will give you the total circumference of a trapezium. Then we've got a parallelogram, which will be that figure there. Parallelogram has the area formula. It's base times by height. So in other words, you've got that side, let's call that the base, times by the perpendicular height, however high that parallelogram is, and that then is the formula for the area of a parallelogram. And just interesting to note where that comes from. If you take that triangle there, that forms there, and you put it on this side here, you will actually be back to an original rectangle. So we've taken away from the original rectangle a little triangle and put it on the right hand side to form the parallelogram. But as we'll see shortly, the area of a rectangle is length times breadth. Now the breadth has become the height of the new parallelogram. The length is now called the base of the parallelogram, but it is exactly the same area as it was before when it was still a rectangle, and that's why it could simply still be base times height, or the original length times breadth. Next figure that we'll look at is the rhombus. Now rhombus is effectively just a parallelogram with four equal sides, or a square tilted to the side. But because we can consider this to still be a parallelogram, we can stick to the same formula for area for a rhombus, and then for both of them, the rhombus as well as the parallelogram, again the circumference will simply be the sum of all four sides. That's how you will get the total circumference of any of those two figures. Then we'll be taking a look at a rectangle, number 4, which is there. Rectangle, like we said before, is length. Any of the sides, call it length, times width or breadth. Let's call it breadth or width, doesn't really matter what you call it, but it's that one side times by the other side will give you the area, and then the circumference will literally again be the sum of all four sides. But since you have that side and that side equal, you could say, for instance, just add those two together and times by 2. However you want to take a look at it, it doesn't really matter. Circumference is just the distance around. And sometimes it's just easier to remember the distance around is the circumference than trying to remember different formulas for different figures. But the choice is yours. You can decide which formula you like for that. Square is the same as a rectangle, except that it also has the same distinguishing property as a rhombus, in the sense that all four sides are equal, but it again has length times breadth for the area, same as the rectangle. Circumference is all four sides added together, or you could say 4 times one of the sides. Remember, for a square, we've got all four sides equal, so the distance around would be the sum of all four sides, or just simply 4 times one of the lengths of the sides, since they're all exactly equal. Again, the old story, do you want to remember a specific formula for a square, or do you want to remember a general formula for circumference, in the sense that it is the total distance around? It's up to you totally to decide. Then we'll take a look at a kite. A kite consists of 4 separate triangles. So you've got that triangle there, that triangle there, that triangle there, and that triangle there. 4 separate triangles, which we'll take a look at just now, the area of a triangle. But for the area of a kite, you will have to work out the areas of all 4 triangles and then add them together. Take note that you've got those 2 triangles equal, so you could just work out one and times it by 2, and the same for these two. You don't have to work out all 4 triangles. You could work out only 2 of them and then multiply each one by 2 to get the total internal area of the kite. But the bottom line is there is no specific formula for the area of a kite. You have to work out the individual triangles first. Circumference, same old story, sum of the 4 sides, distance around the outside will give you the circumference. Then a circle. A circle, we just need to take a look at some theory as well. You'll see there we've got the sector. A sector is the area enclosed by 2 radiuses. So you can see there's one radius, there's another radius, and an arc, or the outer edge of the circle. That is called a sector. A segment is when you've got a chord, a line going from one point on the circle to another point on the circle. That is a chord, and the area enclosed by the chord and an arc of the circle is then called a segment. A chord is, like we said there, is just a line from one point on the circumference to another point on the circumference. The diameter is a chord going right through the middle of the circle. Then it is called the diameter, and half of the diameter, in other words from the midpoint to the outer edge of the circle, is called a radius. Then looking at the formulas for area. Area of a circle is pi radius squared, where we normally use pi as 3,14 or the fraction 22 over 7. Radius is simply whatever value you've got there. The radius of the circle, times it by itself, and then times by 22 over 7, and you'll get the area of the circle. Circumference of the circle is 2 pi radius. That will then give you the circumference of the circle. So just take note, for the circumference we've got the 2 in front, whereas with area we've got the 2 in the exponent for the radius. Don't get confused with those two. And then lastly we'll take a look at a triangle. A triangle will have a base. In other words, it's the side on which this triangle could rest if it was standing on a table. And then there must be a perpendicular height, which is the highest possible point of the triangle. And the area of a triangle would then be a half, times by the base, whichever side you've chosen as the base, times by the perpendicular height, and that then is the area of a triangle. And the circumference, again, just taking the sum of all the sides on the outer edges of this triangle.